Hey YouTube, Jay Kilroy here. We're going to finish up the work stop. We're set up here in the big Kearney Trekker. I keep saying that like I have two. I don't have two anymore. Adam has the small one. I set up the power feed, and I wanted to share with you a couple little tricks on setting up stops to use power feeds effectively in kind of a semi-precise manner. One is you got to know where you are, right? So what I have here is a little just a regular scribe stuck in a drill chuck. Then I've got a ruler down here that you can't see. It's my trusty starred hook rule. But what I have is a couple little magnets on the back, just a couple little rare earth magnets that work quite well at holding the ruler in a position that's usable. And one of the tricks with a Kearney Trekker, I'll move the camera over here. You see the two blocks. These are my two blocks to stop my power feed, to give me the distance that I want. The great thing about a Kearney Trekker is with these blocks, the way you set your travel distance is this OD. I mean, it's not an OD. This outside distance, outside to outside, which right here measures 4 5/8, means I'm going to have 4 5/8 travel on between those two stops, and which is what I'm looking for. So this is it's a nice little trick here. So what I do is I take my little magnets, just kind of stick them on the back here like so, then just press them down. Now this spot right here, there's a punch mark right here, and that's the this end of the slot. And then there's a punch mark down here where this pointer is, and that's the end of the slot on that end. And that gives me exactly the travel that I'm looking for. So what I'm going to do is I'm going to take a 3/4 inch drill. I'm going to pre-drill these two ends just to open the slot up, and then I'm going to put it a 3/4 inch rougher, and we're going to rough the slots out. And then when we're done with one side, I'll pick the piece up, spin it around 180 degrees, put it back down, and carry on about our business. So here's another little good thing to do if you're just getting to know your power feed and how it behaves. Set up your rule here and then run it back and forth a few times and see how it repeats. I mean, this isn't CNC here, so don't expect tenths accuracy here. But that's not what you're paying for, so it's not a big deal. But like I said, I just have this little scribe in the drill chuck. Got my scale propped up here, and I'm just running it up against this stop and seeing how it repeats. And it's pretty good. It probably is, just a few thou here and there. pilot drill action. I don't normally do that. Jake Kilroy, I'm back and finish up this cut. Been waiting to take this last slotting cut on this work stop for days. Work's been driving me crazy. Anyway, before we do that, we're gonna do a little review. First thing we're gonna review is speeds and feeds and cutters. There's been a lot of talk online about Stefan. Gotteswinter just did a great little video. Go check his channel out on the advantages of using carbide tooling, even in manual machines, even in home shop machines, even in machines with low horsepower, and how modern high-tech cutters can benefit you even when you don't think they can. You're told things like, well, if you've got a south bend, you can't really utilize carbide or coatings, whatever. Nah, that's all baloney. Carbide is your friend, let me tell you. The big advantage here is if you're using carbide tooling, especially end mills, in a mill, in a non-production setting, especially if you're cutting a lot of aluminum, they'll last almost forever, right? So, yeah, carbide is your friend. So we're getting ready to take a slot cut, 3/4 inch wide, through almost slightly less than 3/4 inches of material. And this is the cutter we're going to use. It's a Niagara 4-flute, 3/4 inch, carbide fine tooth rougher. In this case, it's got some coating on it as well. And so that's the cutter we're going to use. These are great. This is a great little cutter here. It's short, stiff, rigid, and it's a rougher, and it's got a really nice 1/8 inch radius on the tooth, which means you're not going to break dang tips. Carbide, for as strong as it is compared to high-speed steel, is surprisingly fragile. You drop a cutter like this on metal, and you're very likely to chip an edge or chip a corner, but much less so with that nice radius there. So we're going to talk about speeds and feeds. What speeds and feeds are we going to use for this end mill to cut a slot in steel? Well, where do you find out about this? Well, who makes it? It's a Niagara. I'm a big fan of Niagara cutter. I have no association with Niagara cutter in any way other than as a happy customer. And they make a lot of fine products. And so you go to the Niagara website, right? Google is your friend. And then you'll find something that looks like this. It's a piece of paper. And what it is, it's out there on their website under solid carbide cutters. There's a section that tells you, has a big section where you choose a material, and it gives you these sheets. So one of the other things, once you get the tool, you figured out what you're gonna how fast you're going to run it and how fast you're going to feed it. What are you going to hold it in? Well, you're going to hold it in a tool holder. Right? This is a 3/4 inch 50 taper tool holder with about a 6 to 7 inch reach. Real quickly, if you have a mill of any type, but specifically 40 or 50 taper mill, and you're buying tooling on eBay, this is for you, Brian Block, but you already know this. If you have a mill like that, and you want one, trust me, tooling can be really inexpensive on eBay, but there's always risk from buying stuff, you know, online, used, whatever. And what I think the primary risk buying 50 taper tooling is kind of two primary risks. Stripped out drawbar threads. You know, you buy it, you get it, it's got stripped out drawbar threads. It's really not economical to fix. Damaged diameter here where the tool actually mounts, or stripped out lock screw threads, which is pretty easy fix. But if this is damaged or bell mouthed, it's shot, right? Throw it in the trash. But I think the most common problem that you get with tooling that you buy, with tool holders like this that you buy online, is scarred up surfaces, this taper, scarred up taper surfaces. If you get your tool holders, R8, 30 taper, 40 taper, 50 taper, whatever you've got, before you put anything in the spindle, you clean the spindle. Get your hand in there, spin your hand around, or get you a taper cleaner, they make them, a rag, and get it clean. You don't want anything in there. And then equally, your taper on your tool holders got to be clean. And these, because these big tool holders are used in heavy industry likely, and in production environments, they're much more likely to be damaged or scarred than, you know, R8 taper, I think. You know, much more likely to have undergone heavy use. So this one I bought online, cheap, right? And it had some little nicks. It wasn't really scarred per se. You can't exactly spin one of these. It'd be a real something if you did. But it had some little imperfections. If I run my hand over it like this, I can still feel one. There's one right there. It had some imperfections. A couple of ways you can try to smooth this out. Piece of 600 grit. Smooth this down, some Scotch-Brite maybe. But if you have a raised spot, if you have a high spot, which I've got right there, a little bench stone like this is a little synthetic 600 stone. And find your high spot by feeling it. Don't look for it, feel it. Found it. And stone that off and feel it. Close your eyes. I close my eyes because it allows me to focus when I'm trying to find these little spots. But you don't want any high spots on your tool holder, on the taper before you put it in your spindle. Another thing to look for is chips. You certainly don't want to get a chip up in here, put your tool holder in, tighten that drawbar, and then not be able to get it out. Or damage taper, your spindle taper. These can be replaced pretty easily and cheaply. Your spindle taper cannot. There's one right there. I think you can hear that one. Anyway, I've got it pretty much doctored up here to where it's usable. And you're not trying to remove material per se. I mean, you're not trying to, you know, reshape the taper. You're just trying to knock off the high spots so you don't damage your machine taper. Anyway, I've been at it for a while. So this is of all the tool holders I bought online or used or at auctions, this is probably the worst one I've ever got. So anyway, there we go. Speeds and feeds, and what to watch out for buying used mill tooling. Get back over the machine. Let's make some chips. All right, we're set up here in the mill. We're over our relief hole. It's really just so I don't have to hog out all that stuff with the end mill. We got our, as we've previously done, we've got our travel stops set up. We've got everything all locked down. I'm going to use a little coolant, mostly just to keep the chips out of the way. Alrighty, our stops are working as normal. Our power feed stops set up. Stop us right in the right spot. I've got to go get a little something to clean this up. We're going to cut back the other way and finish up this first slot. Alright, this here's the rest of the depth cup. About 3/8 of an inch, I guess. we made our first pass, we made our first slot in 2 passes. Now we're going to make this slot in 1 pass. So we'll be cutting basically, for all practical purposes, slightly less full diameter of the cutter, deep. We're using a cool mist style coolant system here, and we're gonna go ahead and plunge through this relief hole, and we're just gonna make 1 pass. Oh, hit the wrong button. Alright, cutter's coming in and out of both sides. We got the coolant flowing here. Most of it, like I said, that's just to keep the chips from accumulating. Notice the chips falling off the bottom. That's one advantage of cutting a full depth slot. Alrighty, there we go. 2 slots. Let me get some chips here. You can see the chips are coming off there. Nice little curls. Well cut. So that's the advantage of calculating your chip load per tooth versus just some kind of generic feed rate. Oh, if I'm using high-speed steel, I do X feed rate, whatever. There's some big advantages to going through the math to calculate chip load. So anyway, let's get this baby out of here and take a look. All right, YouTube, pretty much the work stop is done. All I have left to do is make the key. I'm not going to bore you with that. We're going to be able to get back on the faceplate, the angle plate castings here. Now this is complete. I was kind of wanting to stop for setting up the angle plate castings in the mill to face off the big faces and get everything finished up. The 3/4 inch carbide did a wonderful job roughing out, and leaves a very nice finish too. I know they call them roughing end mills, and you look at that serrated edge and you think to yourself, oh, this is going to be just awful. It's going to look like I was using pinking shears for cutting fabric, but that's not the case.
you know, for this purpose, for a slot to pass a bolt through, it's perfectly suitable. There's nothing bad about it at all. So roughing end mills are great. Carbide end mills are great. Cool, modern tooling and all of the cool stuff that goes with it, like variable pitch, you know, variable helix, you know, all this coatings all work. They may not work as well as they would work in a 75 horsepower, 20,000 RPM, 50 taper CNC machine, but they work pretty darn good in your machine. So, you know, give them a try when you have an opportunity. And that's it for that. That's it for the work stop. So I'll be back with you soon. Be safe in the shop.